My name is Sean Mann, and I am part of the Windtalker team. Windtalkers is a small company comprised of 5 energy systems engineers. We strongly believe that wind technology is going to be a major source of renewable energy in the very near future. With this in mind, we have the idea to provide potential clients with a small-scale wind tunnel. This wind tunnel will allow for aerodynamic testing of small-scale wind turbine blades. The tunnel is not only limited to aerodynamic testing, but flow analysis, which provides a large number of potential laboratory experiments. Currently, the only manufacturer of small-scale wind tunnels is in Europe, leaving a vast North American market unexploited. It will be a huge marketing advantage to be based in Canada, as it will greatly reduce the shipping costs for consumers in both Canada and the United States. Now I leave you with Daniel, who is going to talk about the target consumer for our product.
This wind tunnel has several advantages over competing models currently out there in the marketplace. It is small and lightweight and can be carried by one person between classrooms. The wind tunnel has a clear plastic test chamber used for observing the test specimens. It also has a variable transformer which allows the students to control the wind speed in the test chamber. An anemometer within the test chamber is linked up to a digital display which shows the wind speed on a digital readout. The design is simple, cheap, and most importantly, it can be used by students. Most other models are very complex and have to be operated by lab technicians, and this defeats the purpose of lab experiments. The design allows the students to carry out the experiments without worry of damage to expensive equipment. Now, here's Corey, who will talk a little bit more about the financials.
Our target market for this small-scale wind tunnel designs is universities in Canada and the United States. As wind energy becomes a more cultivated form of energy and production increases, more and more universities will look into programs to develop wind energy equipment. In the US and Canada alone, there are over 2,000 universities and colleges. This offers a huge market for potential profits. Assuming 50% of these universities have an engineering program that would like to invest in it, and selling them at approximately $4,500 per wind tunnel, this offers a potential worth of over $4.5 million. This is all subject to change based on how much demand is taken by the universities, but overall, it's a huge market that can be taken advantage of.
The prototype we have built here actually operates with a 550 CFM fan, and this fan can actually be changed for an 825 CFM fan to improve the wind velocity through the test chamber. The 550 CFM fan produces a range from 0 to 11 or 10 meters per second in the test chamber. However, if we implement the 825 CFM fan, we can achieve wind speeds up to around 20 meters per second. This is very advantageous as it's not very difficult to switch out the fans, so universities and colleges would have the opportunity to modify experiments based on what the requirements are for the procedure.
With any new product, there's going to be some risk involved. The main risk that we encountered was functionality. This is why we decided to build a small-scale wind tunnel to make sure that it functioned properly and also not very much maintenance would be involved. Another small risk that we took into consideration was the fact that wind energy may not become a viable source of energy. However, we believe this is not the case, as so much money is being put into this technology now to make it become large. For your convenience and to show the functionality of this wind tunnel, my colleague Sean Pittman is going to run a brief demonstration.
Alright, so this is the prototype that we've built for our small-scale wind tunnel. Starting here, we have the contraction area where the airflow comes in and contracts into the test chamber area. We have the little specimen area here, a nice big opening to put in whatever you need, a small cutout for our anemometer, which will go in and read us our wind speed levels. Then you have the diffuser section and the motor. This unit runs off of a variable transformer, which allows the students to control the power going to the motor. This unit can get air speeds up to 10 meters per second and all the way down to less than 1. So we'll ramp it up right now, and you can see the unit under operation. This test unit is approximately 20 pounds in weight. After investment, we do plan on changing the materials from wood to aluminum, which should give us a couple shave a couple pounds off that weight as well. Now I'm going to pass it off to Andy, who's going to finish up with some concluding remarks.
To conclude our proposal, we're looking for $500,000 as an initial investment, and that will give you approximately 30% ownership of our company. This $500,000 will be put towards material costs and manufacturing costs for the startup of the project to produce the actual prototypes that will be sold to the universities and colleges throughout North America. This $500,000 will be recovered quickly based on the 1,000 schools that are in the North American market. And we're only assuming that each school will purchase one wind tunnel, and only 50% of the schools will be interested. This figure could go up drastically if you consider that such a small-scale wind tunnel could be used also for high school experiments in classrooms, and also it could be used in multiple laboratories, as each group of 4 individuals could work with one wind tunnel. We thank you very much for your time in considering our presentation, and we hope you find our offer not only reasonable but acceptable, and we look forward to working with you in the near future. Thanks on behalf of Wind Talkers.